Hello everyone, welcome to my tutorial on object-oriented programming in Java. Today's tutorial I'm going to talk about abstraction. So abstraction is the process of hiding unnecessary details from the user. Abstraction enables the user to implement more complex logic on top of the provided abstraction without understanding about all the hidden complexity. So in short, we can say that abstraction is a process of hiding your implementation. That means we are going to expose only the implementations which are necessary. The unnecessary implementations is going to be hidden from the user. So abstraction is about hiding something. And there comes the difference. We need to know the difference between the encapsulation and abstraction because both are talking about hiding. So the encapsulation is a process where we are hiding the data. But on the other hand, abstraction, we are hiding the implementation. So this is the difference between encapsulation and abstraction. Now what is the advantage or what are the advantages of abstraction? It avoids code duplication. It increases security since only important details are provided, and also increases code reusability. So that means we are doing what? We are hiding implementation. So what is the mechanism of doing abstraction? There are two ways we can do abstraction in Java using the abstract class and interfaces. We already know about the abstract class and interfaces. So abstract class is a class which may have some unimplemented method, and it can also have some implemented method. So that means when we are using the abstract class as abstraction, we are showing only the implemented method. The unimplemented method is remaining as abstract and the subclass is going to implement it. So that means the subclass is not showing that how it is being implemented. And with the interface, we already know that interface do have all the methods default as abstract. That means any class needing to implement that interface needs to implement the method as well. So now let's take some example. So let's say I have an abstract class shape. And then I have a, let's say, constructor. So that means the abstract classes can have constructors. We need to remember. But what they cannot do is they cannot instantiate, or you cannot create a new instance of the abstract class. So now let's say we have an abstract method and we are saying this. So abstract void area, and we know that whenever you are defining a method to be abstract in an abstract class, we are just going to write the method signature only and no implementation. So this shape can be either a circle or a rectangle. So circle has its own implementation, and we know that area of a circle is pi r square. On the other hand, the rectangle area implementation is length times width. So that means when we are going to write this class, circle extends shape and rectangle extends shape, we're going to do what? We are going to implement area here, and we are just going to write radius into radius, and over here this is going to be area, and then length times width. So that means you can see that I have defined here the area as an abstract, and this is not implemented. On the other hand, here this is implemented. So that means we are not exposing this implementation to the user. So now when I'm going to use this, I'll be writing shape ace equals new circle. See here, I'm not creating a new instance of shape because shape is not a concrete class. So since this is not a concrete class, we cannot create a new instance. But we can create a subclass instance of it, which is new circle. And then when I'm going to access it as dot area, I will be able to access it. Again, if I'm going to create a rectangle, shape r equals new rectangle, and then I'm going to write r dot area, and it will be pointing over here. So the basic thing is I am hiding this implementation and this implementation from the user. This is what the abstraction is. So now let's look into the coding, and I have created a shape class here, and you can see that the shape has a constructor. I mean, the abstract class can have a constructor, and then I have just one method here, which is void get area. And then I have one circle class which is extending the shape, and then I have one constructor. It is taking two parameters, float radius and string s, and I'm passing on this string value to the super constructor, which is this one. Okay, and then I have my own implementation of the get area for this circle. And then when I go to the rectangle, the same thing. It's taking three parameters, and one parameter is being passed on the super constructor, which is coming from the shape class. And then this class also has an implementation of its own, the get area. So that means we are hiding, we are not implementing it here. We are hiding this implementation, and the implementation is actually completed over here. And then I am going to test abstract.java class, and you can see that I have created one instance of circle, but my reference is a shape, and I have another instance of a rectangle. The reference is also shape, and then when I'm going to run it, let's run it. So see, the first one, this one s1.getArea is giving me these two outputs, because whenever I'm creating the constructor here, it's calling it's invoking the super constructor, and in the super constructor we have a print method. We have a print statement, and then over here as well we have a print statement being invoked from the super constructor. And then the get area of the shape, the get area of the circle, and the get area of the rectangle instances or objects are being invoked, and then that is the result you can see here. So the good thing here is, if I would have not implementation here, like let's say if I would have put here get area, so I had to put what? Get area for, let's say, get area circle, and then I had to get area for rectangle. So I had to write all of these codes over here, and the maintainability would be very bad. And the main principle of object-oriented principle is that how much you can do your code reuse. So that means if I separate these functions, or if I separate these methods, okay, and I put those into the implementing class, that is more code reusability perspective. It makes our code more clean. So that's it for today. Thank you.